All right, this is Honors Algebra 2 Pre-Calculus. We're doing 6.7 in Algebra 2. It's our second video, solving exponential equations using logs. So recall that when you have only one x in an equation, we can solve that equation using SADMEP, which is just order of operations, PEMDAS, backwards. Getting rid of exponential expressions, meaning rewriting them in log form, falls into the E category of dealing with exponentials and logs. Without a calculator, you're often going to end up with solutions that include logs. These are the exact solutions. Using change of base, you'll be able to approximate solutions in your calculator, but the exact solution involves a log. So obviously the exception is if the exact value of a given log can be found. So for instance, the log base 2 of 8 is 3, since 2 to the third is 8. So we're going to walk through some examples solving exponential equations. So here we're going to always find the exact answer. You can use the change of base formula to type any of these in your calculator to get an approximate value. All right, so, oh hey, here I have you doing both, exact and approximate. So 2 to the x equals 15. So you can either think of this as rewriting in log form, right? Or you can just take the log base 2 of both sides. The reason I'm taking the log base 2 of both sides is I'm trying to get rid of a 2 exponential, so I just get x equals the log base 2 of 15. This is my exact answer. This is it. That's it. I'm done. Congratulations. If I want to approximate it, the way I'm going to do that is by doing the natural log of 15 divided by the natural log of 2, and I'm going to get that x is approximately, so we'll go over here. I'll inch this way a little bit. Hang on. Sorry, my bad. Okay, cool. So let's do the natural log of 15 divided by the natural log of 2. All right, and I'm going to get it's approximately a 3.906 or 7, depending on if you round or truncate. So this is the approximate answer. Okay, so exact is always better, right? So there are a few exceptions to that. Obviously, if you're doing something in physics and that x represents like a time and you need to know how many seconds have passed or something, you're not going to answer your seconds as log base 2 of 15. That would be weird. But in general, finding the exact answer is really important, and then it's not awful to type it in your calculator if you need to approximate it. All right, so same idea, give it a try. So I'm going to take the log base 7 of both sides because that's going to cancel this side. And on this side, I'm just going to get the log base 7 of 100. That means my exact answer, whole answer, yay, I'm done, is this. This is my exact answer. Yay, congratulations, it's done. If you wanted to type this in your calculator, you would do natural log of 100 divided by natural log of 7, and you would get an approximate value. So natural log of 100 divided by natural log of 7, hit enter, and I get 2.366 or 7, depending on if you round or truncate. Okay, so that's approximate. All right, let's do one slightly harder. So now I actually have to do some solving. So I'm going to go ahead and do my subtraction and addition first, right? So if you look back at these, there was nothing else to solve, right? There was no subtraction and addition. There was no division and multiplication. I got right to the exponent, right? The same thing was true here. No subtraction and addition, no division and multiplication. Oh, look, there's the exponent. But here, there is subtraction and addition. I'm going to subtract that 5 over. So I'm going to get 3 times this 4 to the x is a 26, right? Now, it is worth noting here that 3 times a 4 to the x is not ever a 12 to the x, right? Because exponents happen before multiplication in PEMDAS, right? So the 4 to the x, the 4 has the power, the 3 does not, okay? So please, 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 the only way that this would be, so if you had 3 raised to the x times a 4 to the x, well, yeah, then that's a 12 to the x, congratulations. But this 3 is not to the x power. Please don't ever make it a 12x. Okay, so that's just a separate note. I'm now going to do my division and multiplication and get 4 to the x equals 26 over 3, which stinks, but it is what it is, right? It's just going to stay 26 over 3. When I want to get rid of a 4 to the x, I do it using a log base 4. So the log base 4 of 4 to the x is going to cancel, and on this side I'm going to get a log base 4 of 26 thirds. So my exact answer is the log base 4 of 26 thirds. That's it. Congratulations. Answer. That's my exact answer, right? If I want to approximate that answer, I'm going to do it by typing in the natural log of 26 thirds divided by the natural log of 4, which I'm going to do right now. So the natural log of 26 thirds, oh, my bad, 26 thirds divided by the natural log of 4. And I'm going to get that it's approximately a 1.557 or 8, depending on if you round or truncate, right? So this is my approximate answer. Exact answer and approximate answer, right? Notice you're not always going to be asked to do both. Here I'm asking you to do both. Okay, so go ahead and try P4 without me, and then, pause me, and then you can go through it as I go through it. So I'm going to start with subtraction and addition, right? So sure enough, I can subtract this 20. So I get negative 2 times 3 to the x equals negative 5. Then I do my division and multiplication. I divide everybody by the negative 2, right? So 3 to the x equals 5 halves. Then I'm going to deal with that exponent. I'm going to take the log base 3 of both sides. Log base 3 of 3 cancels, and I get that my exact answer is the log base 3 of a 5 halves, right? So that is my exact answer. If I want the approximate answer, I'm going to type in the natural log of 5 halves divided by the natural log of 3. So natural log of 5 halves, close the parentheses, divided by natural log of 3, enter. And I'm going to get that it's approximately a 0.834, right? So this is my approximate answer. All right, moving on. Okay, so again, I'm going to do my subtraction and addition first. There isn't any. I look and do division and multiplication. Well, I can divide both sides by 2, so I get 5 to the 2x plus 1 equals 14. Now I can deal with that exponent, right? But keep in mind that all of this is inside the exponent. It's like a parenthesis, right? So I'm going to go ahead and take the log base 5 of both sides, because that'll get rid of the log base 5. So I get 2x plus 1 equals the log base 5 of 14. Now this thing is a number, this whole thing, log base 5 of 14. So everything else I'm about to do to this doesn't change that is a log base 5 of 14. So now I go back, now I'm in the parentheses, and I reset and start SADMAP again. So I'm going to subtract 1. When I subtract that 1, please notice that it doesn't affect the 14. The 1 is not inside the natural log, or the log base 5. So if you're unclear, put it at the front. You could put it at the back, but it is very, very important that the log base 5 of 14 minus 1 is not the log base 5 of 13, right? It would have to, so that would be, right, to make that happen, you would have to be doing the log base 5 of a 14 and a 1 inside parentheses. That would be the log, and that's not the situation, right? And then the last thing I'm going to do is do my division and multiplication. So I'm going to get that x is this entire thing all over a 2, right? Now, you could write it, if you wanted, as a negative 1/2 plus, let's say, a 1/2 log base 5 of 14. That would be fine. It is also worth noting that this is not a 7, right? The 2 is not inside the logarithm. The only thing, so the 14 is in the log. That's the only thing in the log. You can't do anything else to that 14, okay? If I want to type this in my calculator, I'm probably going to type this in as negative 1 plus the natural log of 14 divided by the natural log of 5, right? And then I want that whole thing divided by 2. So we're going to do parentheses, negative 1 plus natural log of 14 divided by natural log of 5, close the numerator, divided by 2, and I get an answer. My approximate answer is 0.319 or 320, depending on if you round or truncate. So again, this is my exact answer. This is my approximate answer. All right. Okay. Last one, give it a try. So again, do your division, do subtraction and addition first. There isn't any division and multiplication. I can divide by a 10. So I get 6 to the 4x minus 3 is a 5, right? Then I deal with the exponent, which is going to be the log base 6 of 6 to the 4x minus 3 equals the log base 6 of 5. The log base 6 of 6 is gone. So I have 4x minus 3 is the log base 6 of 5. Again, I want you to remember that this thing, this is going to stay like locked. You can't do anything to the 6. You can't do anything to the 5. So now I'm inside the parentheses, right? And I'm going to start with subtraction and addition, which means I'm going to add the 3. You can't make this a log base 6 of 8. The 3 is not inside the logarithm. So I get 4 equals a 3 plus the log base 6 of 5. Again, log base 6 of 5 is a locked box. You can't change that at all. And then I'm dividing everybody by 4, right? So I'm going to get that my my answer is 3 plus the log base 6 of 5 all over 4. That would be my preferred version of this answer. There are other ways you could write it. Make sure that you don't change the log base 6 of 5, right? If I want to approximate my answer, I'm going to type it in as 3 plus the natural log of 5 divided by the natural log of 6 all over a 4, right? So my x is approximately, we're going to do 3 plus the natural log of 5 divided by the natural log of 6. Close the numerator as well, divided by 4. I get that this is approximately a 0.974 or 5, depending on if you round or truncate. So again, exact answer, approximate answer. And you're not always going to be asked to approximate, so make sure you read the instructions. All right, cool. Next video.